to special right triangles. So today we're looking at two concepts. A special right triangle is the instances in which you only need one side of triangle to solve for the other two. So here you go. The first one we're going to look at is the 45, 45, 90 right triangle. These deal with the angles of a triangle, the angles. So in a 45, 45, 90 triangle, the hypotenuse is square root of 2 times as long as both of the legs. Because remember, since we have a 45, 45, 90, we know that these two sides, that side and this side, are going to be the exact same measurement. So here's a diagram that kind of depicts how I want you to think about this. So here's the diagram. In a 45, 45, 90, again, here's your 45, 45, 90 is talking about the angles. So in a 45, 45, 90, your two side lengths are going to always be the same, this x measurement. And whatever those two side lengths are, the hypotenuse, or the 90-degree side, is going to be square root of 2 times bigger than whatever that is. And we're going to get into more showing you exactly where this comes from tomorrow. But I want you to get the basics today. So let's do a practice problem. So draw this triangle for me, and I want you to try and apply the same concept. So if you're given a side length of 7, we're given this down here, that this is 45 degrees, immediately, what do you know? Yeah, well said. You know that this angle is also 45 degrees. Why? Because we have our right angle, and we have two 45-degree measurements. Because all triangles interior is 180. Good. So, what are we going to solve for first? Well, it should be pretty easy. If it's 45, 45, 90 triangle, what is this side length, this empty other leg, going to be? Yeah, correct. Since this is 7, that has to be 7 as well. Then what do we know about the hypotenuse of now a special right 45, 45, 90? We know that it is square root of 2 times bigger. So if these two are 7, then our hypotenuse is just going to be 7 times the root of 2. 7 times the root of 2. And again, that gives us our x, those two are the same, and then our x times the root of 2. Or what would x equal in this situation? Well, x is 7. Questions, comments, concerns on this one? Okay, this is the easier one. Now let's look at the more challenging one. That is the 30, 60, 90 triangle. This one is decently challenging to do. So, let's just worry about this right now. Okay. So in a 30, 60, 90, again, that's talking about degrees of the triangle. The hypotenuse is twice as long as the shortest leg. Then the longer leg, remember 2 legs in a right triangle, the 2 legs make that right angle. The longer leg is going to be square root of 3 times as long as the shortest leg. I know that sounds a little confusing. I have a diagram that's going to hopefully help you out. So again, if you need to pause to write this down, go ahead. It's crazy. As I teach, I still move my hands and look at the class, even though you guys aren't here. But you better be listening right now. So, here's a 30, 60, 90 triangle. Because that's 30 degrees. You see that? That's 30 degrees right there. So, like it said, the side opposite of our 30 degrees, or our shortest leg, is our base always. What I want you to write down and remember, in a 30, 60, 90 triangle, we always solve for shortest leg. Okay, very, very important concept. We always solve for the shortest leg. And again, up here we have 30. Remember, 30 degrees is our x. It's our base leg. Our 60-degree side, that would be our longer leg. That is x times the root 3. And I'm going to show you how we all get this eventually. And then from 30 to 90, we know that's going to be just 2 times larger than our smallest side. Any questions? Okay. So, we're going to give you one practice problem now, and then in class tomorrow, we're going to get more into it. Well, that one's got the answer already to it. I was practicing this earlier. Well, that's done. We're not going to do that one then. So let's look at a more challenging one. Let's look at this one. Here, we're going to do this example right here. So, again, we have a 30, 60, 90. Where 30 is our shortest side, it's our x variable. Our longest leg is root 3 bigger, and then our 90-degree side is 2 times bigger than whatever that shortest side is. So right now, you should be shouting out, what side do we always solve for in a 30, 60, 90? Go ahead. You all said we solve for the shortest side. So the only piece of information we're given right now is this 20. 20 is on what? Yeah, 20 is on the hypotenuse. So what is the hypotenuse? It's this part. So how are we going to go from having 2x to just getting to figuring out what our original is? Well, since 20 is our 90-degree side, we can set 20 equal to 2x. And if we just divide by 2, we can figure out that x equals 10. What is that x equals 10? Don't ring the bell. The kids can't leave. They're at home. So what does that x equals 10 mean? That means that our shortest side, our x side, or our 3rd-degree side, is 10.
Austin, 10 minutes to the attendance office, please.
Did you hear that, Austin? You know, I don't have an Austin. So, and how do we know that that 10 is there? Well, because this is 30 degrees. Okay, so our last side we got to solve for is our 60-degree side. Or up here, it's our smallest, our x times the root 3. So since we figured out x is 10, what is our second longest side going to be? 10 times the square root of 3. So it's a different way to solve. Yes, we're going to practice this a lot more, but you got to know the basics so we can get into it right away tomorrow. So go online quiz, super easy to finish. Have a great time. It's been fun. Thank you. I'll take a bow. Everyone should be clapping right now.